All right, so today's lesson is over 3.3, which that's our section, and the title is Zeros of Polynomials. So it's a complete video lesson, so you can start it today on Tuesday, finish it up if you need to today, or you can work on it on Wednesday since I won't be here. So you've got the next 2 days in class to work on this. So we're going to start with what's called the factor theorem, and we introduced this a little bit the other day. The factor theorem states that for any polynomial function, f of x, x minus k is a factor of the polynomial if and only if f of k equals 0. So this goes back into what our remainder theorem says. So remember what we talked about in 3.2 was that if I plug in k and I get out 0, that means that the remainder, when I synthetically divide f of x by x minus k, is 0. So all this is saying here is that if I do f of x, this function, I divide it by x minus k, if I get 0 as my remainder, or if I get 0 when I plug in k, then what that means is that x minus k is a factor. That means it divides evenly. We talked about that a little bit with 3.2, and we finished that up on Monday. So if I'm supposed to solve this problem by factoring, just to kind of help you solidify what this means, I have 3x squared plus 11x minus 20. Well, first of all, I know this factors because my product sum chart, my product needs to be negative 60, my sum needs to be 11. It definitely looks more like gum. My sum needs to be 11. Well, my factors would be a positive 15 times 4, because 15 times 4 is 11. So then you factor. So whether that means that you rewrite this as 4 terms, oh, that should be a negative 4, sorry, I didn't specify that, negative 4x minus 20. Or if that means that you swing and divide x squared plus 11x minus 60, and you have x plus 15 divided by 3 times x minus 4 divided by 3. No matter what, however you factor, so that's what you should be doing right now is factoring, you end up with factorization of x plus 5 times 3x minus 4. And this problem originally equaled 0, so I'm going to set it equal to 0. So this is my final factorization. But it didn't ask me just to factor it. It said to solve by factoring. And if I'm solving by factoring, that means I'm taking each of my factors, so x plus 5 and 3x minus 4, and I'm setting them equal to 0, and I am solving. So I would minus 5 from both sides, and I'm going to get x equals negative 5 for one of my answers. And then I'm going to add 4 to both sides. So I get 3x equals 4. And then divide by 3. And I get, for my second answer, x equals 4/3. So these would be my two solutions. So that tells me a couple things. Number one, that tells me that negative 5 is a 0 of f of x, of our function that we were working with. It also told me that 4/3 is a 0. That's what that means when I've solved it, that it's a 0. So we've got a couple questions over here. So the first question says, what happens when you plug in your two solutions? Okay, so I'm going to go back to the original problem, which my original problem, recall, was 3x squared plus 11x minus 20. And I'm actually going to plug in, I'm going to do this twice, so 3x squared plus 11x minus 20, and I'm going to plug in the two values that I got for 0. So I'm going to plug in negative 5, because that was one of them, and then I'm also going to plug in 4/3. And then we're going to type it all in the calculator. Or you can do it by hand. I'm going to do it by hand because I don't have a calculator with me. So 3 times negative 5 squared, well, that'd be 3 times 25, so 75. 11 times negative 5 would be negative 55 minus 20. Well, if I do 75 minus 55 minus 20, I get 0. Recall that the reason that we get 0 here is because negative 5 is a 0 of the function. That's what that means. What that means to be a 0 is that if you plug in that number, you're going to get an answer of 0. That's one of the things it means. So I'm going to do that with the other one. So 3 times 4/3 squared, that's going to work out to be 16 over 3. Plus 44 over 3. And then minus 20 would be 60 over 3. And 16 plus 44 over 3, 16 over 3 plus 44 over 3 minus 60 over 3 is going to give me 0. And again, that makes sense because think about what we just talked about. We said that when we plugged in -5, we got out 0. The reason that happened was because -5 is a 0 of the function. We figured that out because we did our solving over here. We solved and we said, hey, -5 is a 0. That's what all of this did. So the same thing has to be true of 4/3. So it makes sense that when we plug in 4/3, we get 0. If we didn't get 0, that would cause a problem. And the reason we got 0, again, is because 4/3 is a 0. So that means when I plug in 4/3, that is a 4/3 there. When I plug in 4 over 3 into my problem, I should get 0. So that's the first thing that we need to notice about this. And we said that a couple times. We said that a couple different ways. I'm just trying to get you to understand this idea of how all of these things are related. So the second thing, the second question asks us, what happens when you synthetically divide by one of the factors? So what I want to do here is we're going to take our original problem, 3x squared plus 11x minus 20. So 3x squared plus 11x minus 20, and we're going to divide that by one of our factors. So specifically, we are going to divide that by x plus 5. That's one of my factors. We're going to divide by that one because it's easier. We can't divide by 3x minus 4. Well, we can just, without doing a little bit of work. So we're going to divide by x plus 5. We're going to do synthetic division here. So I'm going to draw my box. I'm going to put -5 outside. Remember, we got to switch our sign. My coefficients are 3, 11, and -20. So I'm going to drop down my 3. And then I multiply by -5. So 3 times -5 would be -15. 11 minus 15 would be -4. And then I multiply again times -5. -4 times -5 is a positive 20. And I get, lo and behold, 0, which is what I should get. Remember, this is my remainder. And also keep in mind that the remainder theorem says that when I plug in that number, that should be my remainder. So this number right here, this 0, should have been the same as that 0 because that's two different ways to get my remainder. But if I go back and look at the rest of this problem that I ended up with, this was my constant. And this is the coefficient of x. So I end up with 3x minus 4. Well, 3x minus 4, we've seen that before. Do you know where we've seen that before? We saw it over here in the factorization, right here. That 3x minus 4 is the same 3x minus 4 you're seeing here. So what this means is that if I divide by one of my factors, I'm going to get the other factor. So as long as I know one factor, I can find the entire factorization of my problem. So let's find out if x minus 1 is a factor of these problems. We've got a couple ways to figure that out. One, we can use synthetic division to see if the remainder is 0. Number 2, we can plug in k, which in this case would be 1, and see if I get 0. Either way, if I get 0, that tells me it's a factor. So I'm going to do one of each. I'm going to synthetically divide on this problem. So let me make sure we see. We're trying to figure out if x minus 1 is a factor. So that means when I synthetically divide, I need to put a -1 on the outside. I'm sorry, a positive 1. Apologize, that should be a positive 1 there. Okay, so I'm going to fill in my synthetic division here. I'm going to use my coefficients. So 2, 0, 3, -5, and 7. Remember, there's got to be a 0 there because I don't have an x cubed term. So I'm going to bring down my 2, and then I just multiply. 1 times, that's easy because I'm multiplying by 1 each time. 2 times 1 is 2. 0 plus 2 is 2. And then I do it again. I multiply by 1. 2 times 1 is 2. 3 plus 2 is 5. And I multiply by 1. Negative 5 plus 5 is 0. Sorry, let's try that again. 5 times 1 is 5, and negative 5 plus 5 is 0. Then I multiply again, and 7 plus 0 is 7. So look what I got here. I got a remainder of 7. So what that tells me several things. That tells me, number one, that 1 is not a 0 of f of x. That's the first thing it tells me. The second thing it tells me is that x minus 1 is not a factor of f of x. That's the two things I know. And the reason I know that is because I got 7 here and not 0. So the other thing I could have done was I could have taken that number. I could have taken 1 and I could have plugged it in for all of my x's. And guess what? If I'd done that, I still would have gotten 7. They're going to give me the exact same thing every time. So let's try that, just to prove that it really does happen. So we have 2 times 1 to the 4th plus 3 times 1 squared minus 5 times 1 plus 7. Well, 1 to the 4th is 1. So this becomes 2 plus 3 times 1 squared. Well, 1 squared is 1. So that's 3. Negative 5 times 1 is negative 5 plus 7. So 2 plus 3 is 5. Minus 5 is 0. Plus 7 is 7. Hey, guess what? I got the same thing both times. And again, I should have. If I didn't get the same thing here and here, I would have done something very wrong. That these two, whether you synthetically divide or you plug it in, they should always produce the same result. And either way, because I didn't get 0, that tells me that 1 is not a 0 and that x minus 1 is not a factor. So we're going to try that for the next problem. So we're going to synthetically divide again by 1. So 1 on the outside. On the inside, 3, negative 2, 1, negative 8, 5, and 1. Drop down my 3, multiply by 1. 3 times 1 is 3. Negative 2 plus 3 is 1. Multiply by 1. 1 times 1 is 1. 1 plus 1 is 2. Multiply by 1. 2 times 1 is 2. Negative 8 plus 2 is negative 6. Multiply by 1. I get negative 6. 5 plus negative 6 is negative 1. I multiply by 1. Negative 1 times 1 is negative 1. And 1 minus 1 is 0. So, look, I got 0. That's what I'm looking for. Because if I get 0, that tells me a couple things. That tells me, number 1, that tells me 1 is a 0 of f of x. Number 2, it tells me that x minus 1 is a factor of f of x. I learned both those pieces of information just from simply knowing that the remainder was 0. Now remember, I could have very well, instead of doing synthetic division, gotten the exact same result by taking the problem 3x to the 5th minus 2x to the 4th plus x to the 3rd minus 8x squared plus 5x plus 1, and plugged in 1 every time I saw an x. And then just do my math. So 3 times 1 to the 5th, well, that's just 3. Negative 2 times 1 to the 4th would be negative 2. 1 to the 3rd is just 1. Negative 8 times 1 squared would be negative 8. 5 times 1 is 5. And then plus 1. And then I do my math. 3 minus 2 is 1. Plus 1 is 2. Minus 8 would be negative 6. Plus 5 would be negative 1. Plus 1 would be 0. Which again, I should have gotten that. And that makes sense. Because here I got 0. These two should always be the same. Every single time. So again, that just proves the fact that 1 is a 0 of f of x, and x minus 1 is a factor of f of x. All right, so how does doing all of this, how does knowing about the 0 and all that stuff help us? So this next problem says to use synthetic division to factor given that 5 is a 0. So this is critical here to know that 5 is a 0 of this function, because that tells me two things. That tells me that x minus 5 is a factor. That's one thing it tells me. And then the other thing that it tells me that when I synthetically divide, my remainder is going to be 0. That's what it means to be a 0, is that my remainder is 0 when I plug that number in. So that's what I need to do, is I need to synthetically divide this problem by 5 and see what I get. So I'm going to set it up. So I have on the outside 5 and on the inside 6, negative 37, 32, and 15. So I'm going to bring my 6 down, and then I multiply by 5, which is 30. Negative 37 plus 30 would be negative 7, and then I multiply, and I get negative 35. 32 and negative 35 is negative 3. And then I multiply, and I get negative 15, and 15 minus 15 is 0. Hey, we knew that's what it should have been, because it said that 5 was a 0, which means that my remainder should have been 0. And guess what it was? Okay, so let's look at this problem now. Well, this is my remainder, this is my constant, this is x, this is x squared. So applying the division algorithm, so think about what we did with the division algorithm. We can say that 6x cubed minus 37x squared plus 32x plus 15, so my original problem, is equal to x minus 5. I picked that because that was what I factored by, what I divided by, times 6x squared minus 7x minus 3. And I came up with that from what I got when I synthetically divided. So I've begun to factor this problem that wasn't factorable to begin with. I've started to factor it just knowing one factor. So let's see if we can factor it further. So can we factor 6x squared minus 7x minus 3? Well, I need my product sum chart. My product needs to be negative 18. My sum needs to be negative 7. Well, that factors, because negative 9 and 2, when I add them, it's going to give me negative 7. So whether you swing and divide or you do factoring by grouping, it doesn't matter. You're going to end up with 2x minus 3 times 3x plus 1. Don't forget to bring down that x minus 5. And what we have just figured out, what we have just done, this right here is the complete factorization of my original problem. It means if I were to try and completely factor 6x cubed minus 37x squared plus 32x plus 15, I should get that. Well, okay, what is that? Like, how do we prove that? How do we justify, how do we verify that that's the correct answer? Well, we work the other direction. We take our answer, 2x minus 5 times 2x minus 3 times 3x plus 1, and we FOIL it, and we do a lot of multiplying, and we see if we get what we started with. It's the only way to check to see if the factorization really is what we say it should be. So x times 2x would be 2x squared. X times negative 3 would be negative 3x. Negative 5 times 2x would be negative 10x. Negative 5 times negative 3 would be a positive 15. I'm going to go ahead and combine my negative 3x and my negative 10x together because I can. And it's really going to give me negative 13x there. And now I'm going to multiply all of that times 3x plus 1. 2x squared times 3x would be 6x cubed. 2x squared times 1 would be 2x squared. Negative 13x times 3x would be negative 39x squared. Negative 13x times 1 would be negative 13x. 15 times 3 is 45x. And then 15 times 1 would be 15. So then simplifying, I would have 6x cubed. I can combine these two and I get negative 37x squared. I can combine these two and I get 32x plus 15. And, well, what do you know? This right here is the same thing as what we started with in my very, very, very original problem up there. 6x cubed minus 37x squared plus 32x. 6x cubed minus 37x squared plus 32x. So I just factored. Okay, so there's this super fancy theorem that's called the rational zero theorem. It says blah, 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 blah. Basically, what all those blahs mean is that if you take the factors of a constant of some polynomial, remember that's the term without x, so the constant is the part without x, and you take the factors of the leading coefficient is the one with the biggest degree, and you divide those, then what you come up with is a list of possible zeros for your function. And your actual zeros have to come from that list, if they're real, at least. The possible real zeros. Maybe we should say that. But it's the possible real zeros. So, okay, all this mess to apply to a problem, because it's like, this doesn't make sense if you just read it, but let's look at a problem and see what happens. So, we have 8x to the fourth minus 26x to the third minus 27x to the second plus 11x plus 4. So, got a couple questions. First question, how many zeros are there? Well, the answer to that is simple. There's going to be 4. Whatever the degree of the polynomial is, there will be that many zeros. And that is called the number of zeros theorem. So that shows up over here. A function defined by a polynomial of degree n has at most n distinct zeros. So it can have at most 4 distinct zeros. The second question says, how many real or imaginary? List all possibilities. Well, this one gets a little more complicated. So here's what you have to remember is that imaginary zeros come in pairs. Imaginary zeros come in pairs. So if there could be potentially 4, then let's list all the possibilities. I'm going to do mine in different colors. So our first possibility is that I could have 4 real zeros. That's my first possibility, is I could have 4 real zeros. My second possibility is that I could have, and I'm going to list this in a different color so we can see that it's a different option, is that I could have 2 real and 2 non-real. That's a possibility. And my third possibility is that I could have 4 non-real zeros. So, okay, that makes sense that those are the things we could have because, like, just checking our math, 4 is the same as 4. 2 plus 2 is the same as 4. 4 is the same as 4. But the question is, why could I not have 3 real zeros? Because notice when I was listing it, I skipped that. I skipped 3. Okay, well, if I had 3 real, I would have to have 1 non-real. Because 3 plus 1 is 4. But the problem with that is that non-real, the imaginary, they come in pairs. So I can't have 1 non-real. I can only have 2 non-real, or 4 non-real, or 6, or 8. I have to have an even number of those. That's the only possibility. So since I can't have 2 non-real, then 3 real ones. Since I can't have 1 non-real 0, 3 real is not an option. So anyways, all this math to say is that these are my possibilities here. We're going to talk about this over and over again. So if you're like, what, I don't quite understand that, it's okay, we got time. So now to actually start figuring out what my zeros are. Because I know like what kinds they are, like reals and non-reals and all that stuff. Well, I know my options. But I don't actually know like if I have any real ones. So we need to figure that out. So what the rational zero theorem is, the thing we just looked at on the previous screen, says that if I take my factors of my constant, well, my constant term is the last term, which in this case would be 4. And that's this 4 right here. And I divide it by my factors of my leading coefficient. My leading coefficient would be 8. Then I'm going to come up with all of my possible factors. I'm going to come up with a list of some numbers. And from that list of numbers, I'm actually going to be able to figure out what my real factors are. So let's talk about our factors of 4. My factors of 4 are 1, 2, and 4. That's all the things I can divide 4 by. And I can go a step further and not even just 1, positive and negative 1, positive and negative 2, and positive and negative 4. Okay, well then I need to also figure out my factors of 8. Well, my factors of 8 are positive and negative 1, positive and negative 2, positive and negative 4, and positive and negative 8. So to figure out my list of my factors, I need to divide everything on top by everything on the bottom. So we're going to start with 1. We're going to do positive 1, negative 1, divided by 1. And then we're going to do positive and negative 1, divided by 2. And then we're going to do positive and negative 1 divided by 4. And lastly, we're going to do positive and negative 1 divided by 8. Positive and negative 8. Okay, well, I can only simplify one of these because positive negative 1 divided by positive negative 1 is just going to be positive and negative 1. So I currently have 2, 4, 6, 8 possible zeros. I'm getting 2 because I have a positive 1 and a negative 1. That's 2. Positive 1/2 and a negative 1/2. That's 4. Positive 1/4, negative 1/4. That's 6. Positive 1/4, negative 1/8. That's 8. So then I'm going to go through and do the same thing with 2. So now I'm going to do 2. So I have positive and negative 2. Divided by positive and negative 1. And then I have positive and negative 2 divided by positive and negative 2. And then positive and negative 2 divided by positive and negative 4. And lastly, I have positive and negative 2 divided by positive and negative 8. Well, 2 divided by 1 is 2, so there's another pair. 2 divided by 2 is 1, but notice I already had 1 here. Well, I don't need to write that twice. There's no reason to do the math twice. I'm going to mark this one out because it already gave me that answer somewhere else. 2 divided by 4 would be 1/2. Well, again, I already had a 1/2 here, so I don't need this one, so I can mark that one out. And then 2 divided by 8 would be 1/4. And I've already got that, so I can mark that out. Okay, so I gained a couple. Not many, but I gained a couple. Okay, so moving on to my last number on top, 4. So I have positive negative 4 divided by positive negative 1. And then I have positive negative 4 divided by positive negative 2. I have positive and negative 4 divided by positive and negative 4. And lastly, I have positive negative 4 divided by positive and negative 8. Okay, so then checking my math. 4 divided by 1 is 4. That's a new one. I haven't had a 4 anywhere. 4 divided by 2 is 2. But I already got a 2, so that one's out. 4 divided by 4 is 1. I already got a 1, so that's out. 4 divided by 8 is 1/2. I already got one of those, so that's out. So I have 2, 4, 6, 8, 10, 12 possibilities for my zeros. So I'm going to make a table. I'm going to make that on the next page with all this information in it. So I've got a big table here. So my possible zeros, that's my p's divided by my q's. My first one was 1 and -1. Then I had 1/2 and -1/2. Then I had 1/4 and -1/4. And there was 1/8 and -1/8. And then there was 2 and -2, and then 4 and -4. So all of these are those numbers we just came up with on that last page. Every single one of those is those numbers we came up with on the last page. And we're about to just plug them in, and we're going to see what happens. That means we're going to take these numbers, we're going to take our function, which says 8x to the 4th, but instead of x, we're going to put 1. 8 times 1 to the 4th minus 26 times 1 cubed minus 27 times 1 squared plus 11 times 1 plus 4, and I'm going to see what it gives me. Okay, so when I plug that in, I'm going to get -30. So is that a 0 of the function? The answer to that is no, because if it's a 0, I know it's a 0 because this number will be 0. So I'm going to do the same thing. I'm going to plug in -1. Well, guess what? When you plug in -1, you get 0. So that is an actual 0. Okay, then I'm going to plug in 1/2. And when you plug in 1/2, you get 0. So yes, it's a 0. And then I'm going to plug in -1/2, which gives me -4.5. Is that a 0? Nope. And then I'm going to plug in 1/4. And I get 4.6875. So that's not a 0. Then I'm going to plug in -1/4. And that gives me 0. So there we go. I'm up to 3 now. That's good. I'm going to plug in 1/8. And I get 4.9 something, so it's definitely not. Then I'm going to plug in -1/8, which gives me 2.26. So that's for sure not. Then I'm going to plug in 2. 2 gives me -162. So nope, that's not a 0. And I'm going to plug in -2, which gives me 210. So that's not a 0. Then I'm going to plug in +4. And +4 gives me 0. So yep, that one's an actual 0. And I'm going to plug in -4. And that was 3,240. So that's definitely not a 0. So notice that when I did this, that only a handful of these, in fact, let's count them. 1, 2, 3, 4 of these gave me a yes. 4 of them are actually zeros because they actually gave me 0. Think back to one of the questions we asked on the last page was how many zeros are we going to have here? We're going to have a max of 4. Look, I found them all. Oh my gosh, this is so wonderful. Because if I know that -1 is a 0, then that means that x plus 1 is a factor. And if I know that 1/2 is a 0, ooh, now this one gets a little tricky. I know if 1/2 is a 0, let me actually just write these over here. So this was, just so I can see and I can zoom in. So this was -1, this was 1/2, this next one was -1/4, and the last one was +4. Okay, so I can zoom in a little bit and work. All right, so if -1 is a 0, then that means x plus 1 is a factor. If 1/2 is a 0, that means that 2x minus 1 is a factor. So pay attention to where things went. My denominator became my coefficient of x, and my numerator was still, sorry, I'm trying to get another color here. My numerator was still the coefficient at the end. It still switched signs. Okay? So then negative 1/4. Well, that would become, just kind of using the same logic from the last one, that's going to become 4x plus 1. And then my final one, that is x minus 4. So I have now factored this entire problem without actually factoring. It's kind of wonderful. So x plus 1 times 2x minus 1 times 4x plus 1 times x minus 4. If I were to multiply all of this back out, guess what I would get? 8x to the 4th minus 26x to the 3rd minus 27x squared plus 11x plus 4. And I promise you that it would work. Promise, promise, promise. So we just factored this entire problem without actually factoring. We just used what we know, that if we get a 0 when we plug a number in, then it's going to produce a factor for us. So we used that and worked backwards and came up with our entire answer. And think about it. How many real factors did I have here? We said this a second ago. Well, there was real zeros. There was 1, 2, 3, 4. So that meant that there was 4 real zeros. Okay. So now we're just going to do a rough sketch of what this graph would look like. It's not going to be 100% accurate by any means, because we're for sure just kind of guessing at where things are. But let's see, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So let's start with what we know. Well, we know that our y-intercept is positive 4. I got to point at 4 on the y-axis. And the other thing that I know is that based on my equations, sorry, there's a typo here. This should be, and you're probably like, wait, Miss Grimm, that's not right. I know, this should be a plus 1 there. Okay, I just copied that from the previous page. I copied it wrong, though. Okay, so the other thing that we should know is that if x plus 1 is a factor, remember that means that x equals negative 1 is a 0, so it's going to cross the x-axis at negative 1. And then if 2x minus 1 is a factor, it's going to cross the x-axis at 1/2. And if 4x minus 1 is a factor, then it's going to cross the x-axis at negative 1/4. And if x minus 4 is a factor, then it's also going to cross the x-axis at positive 4. So I'm going to put a point out there. So I know enough points to get a substantial picture of what the graph's going to look like. It's not going to be 100% accurate. The other thing that I know, and this is something that's important to know, is that if anything is even exponented, it has an even exponent for its leading exponent, like the biggest one, then it's going to either open up or it's going to open down. It's not ever going to do this weird thingy like this where it has opposite directions. That's all your odd stuff. Your even stuff opens the same way, and this one's positive, so it's going to open up. So that means it's going to come down, it's going to go back up, it's going to come down, it's going to go back, let's try that again. It's going to come down, it's going to go up, it's going to come down. Someday I'll get this right. And it's going to look something like that. Now, is that a perfect looking graph? No, not at all. But we at least have some idea of what the graph is supposed to look like. And that's what we're trying to figure out. So, type that in Desmos. Type in 8x to the 4th minus 26x to the 3rd minus 27x squared plus 11x plus 4. And see if you get a graph that looks something like that. I promise you, you will. Okay, so we're going to do all that again. Determine the factors of 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2. So the first thing we're going to do is we're going to list out all of our possible factors. To find our possible factors, I'm going to take my factors of 2 and divide it by my factors of 6. Well, my factors of 2 are 1 and 2. That's it. My factors of 6, there's a couple more. There's 1, 2, 3, and 6. So now all I have to do is actually divide those. So let's see. We start with 1, positive negative 1, divided by positive negative 1. And then positive and negative 1 divided by positive and negative 2. And then positive and negative 1 divided by positive and negative 3. And then positive and negative 1 divided by positive and negative 6. Then going through the math, well, positive negative 1 divided by positive negative 1 is just positive negative 1. So there's a pair that's possible. That's still going to be 1/2. That's possible. 1/3, 1/6. All right, now I'm going to do the same thing with 2. So positive and negative 2 divided by positive and negative 1. Look at the colors if you have no idea where I'm getting these numbers from, by the way. Positive and negative 2 divided by positive and negative 2. Positive and negative 2 divided by positive and negative 3. And positive and negative 2 divided by positive and negative 6. Well, 2 divided by 1 is 2. That's a new one. I haven't seen that one yet. 2 divided by 2 is 1, so that's out. 2 divided by 3, can't do anything with that. Hadn't seen that one yet. 2 divided by 6 is 1/3. Oh, I already got that one, so that one's out too. Okay, so I have 2, 4, 6, 8, 10, 12 possibilities. All right, so I'm going to make a chart. So I'm going to fill in all my possible zeros, all those numbers we just came up with. Don't forget the positive and the negative form of them. So then we need to plug all those in, and I would just use your calculator to do that. Like, I would not try and do it all by hand, okay? Would not by any means try and do it all by hand because that's going to take you way too long. So I'm going to go ahead, I'm going to pause it, and I'm going to plug them all in, and then we can see what we get. Okay, so plugged them all in, and I ended up with 4 that gave me a value of 0. So if I have 4 that gave me a value 0, then that means I have 4 that are actual zeros of the function. So I'm just going to put a y there to denote, yes, it is an actual 0. And if they're actual zeros, that means I can get factors from them. So if my first 0 was 1, then my factor was x minus 1. Remember, we switched the sign. When we're going from the possible zeros to my factors, we need to switch our sign. We're going from the possible zeros to the factors. We need to make sure we switch our sign. So my next factor was, or next 0 was negative 1/2. That's going to give me a factor of 2x plus 1. 1/3 is going to give me a factor of 3x minus 1. And negative 2 is going to give me a factor of x plus 2. So I have now completely factored this problem. It'd be x minus 1 times 2x plus 1 times 3x minus 1 times x plus 2. That'd be my complete factorization. And again, we could FOIL all that out and do all the multiplying, and guess what we'd end up with? We'd end up with 6x to the 4th plus 7x cubed minus 12x squared minus 3x plus 2. And that's what we were hoping for. So we factored. Okay, so we're going to do a little bit of work backwards here. We're going to talk about, like, now instead of finding the factorization, I have the factorization, and I'm actually going to be working backwards to find the polynomials. Thinking about the last problem we did, that instead of getting an answer or getting the 6x squared, or 6x to the 4th problem to start with, we're getting what we got as our answer, that x minus 1 times 2x plus 1 times 3x minus 1 times x plus 2, and we're going to work backwards to find the original polynomial. So I need to just kind of introduce this idea by talking about this polynomial. X minus 4 times 3x plus 2 times x minus 5 to the 3rd times 2x minus 7. So first question is, what are the zeros of the polynomial? That's the first thing we need to know. Well, that's easy. If my factor is x minus 4, my first 0 is 4. The second thing, if my factor is 3x plus 2, my next 0 is negative 2/3. If my third factor is x minus 5, then my 0 is x equals 5. And then for my final one, 2x minus 7, my factor is 7/2. Now, the only thing that makes this a little bit different is that, and the one thing I have to add here, is that because I have this exponent of 3 here, notice none of the other ones had an exponent of 3, that means that x equals 5 has a multiplicity of 3. And that doesn't affect like how we determine the zeros, but what it tells us in a second is we're going to get somewhere it tells us we have a multiplicity of something. We just have to make sure we list that factor that many times, okay? So this here, remember, if it's x minus 5 to the third, that really means that I have x minus 5 times x minus 5 times x minus 5, and I would end up getting 5 a total of 3 times. That's where that multiplicity of 3 comes from. So, if I know a polynomial, it tells me a is 1, that's important for something later. For now, we're going to ignore that information. With zeros of -1, +2, and 4, then I can actually work backwards and I can write my polynomial. So if my 0 is -1, my factor is x plus 1. If my 0 is 2, my factor is x minus 2. And if my 0 is 4, my factor is x minus 4. Now, this whole thing where it says a equals 1, what that tells me is that there's a 1 right here in front of everything. Okay, well, that's easy enough to figure out. Okay, so if I know this, I can do a lot of math. We know how to FOIL. We're good at foiling, theoretically. X times x would be x squared. X times -2 would be -2x. 1 times x is 1x. 1 times -2 is -2. And I'm supposed to multiply that by x minus 4. I'm going to go ahead and simplify. -2x plus 1x is actually -1x. And then I'm going to do that again. X squared times x would be x to the third. X squared times -4 would be -4x squared. And then -1 times x would be -1x. And then -1 times 4 would be positive 4x. -2 times x would be -2x. -2 times -4 would be a positive 8. So this would be x cubed minus 5x squared plus 2x plus 8. And that would be my polynomial. So I worked backwards from my zeros to find out what my polynomial was. Okay, well that was easy enough, but part of the reason that one was so easy, just to be honest with you, was because it had this coefficient where a was 1. That was important. So what happens if a isn't 1? Well, we still start off the same way. That we have zeros of -1, 2, and 4. And we're also given this information that f of 1 equals 3, and we're going to get to that in a second. Okay, so we're going to start here. That if I have a 0 of -1, that means I have a factor of x plus 1. And if I have a 0 of positive 2, then I have a factor of x minus 2. And if I have a 0 of positive 4, then I have a factor of x minus 4. And I know that I'm going to have to multiply this by some number a because we don't know what a is, but it did specify over here that a was not equal to 1. I know that much. Okay, let's go ahead and do all the foiling. Okay, so we could go ahead at this point. We could FOIL like we know how to do, like we did on the previous problem. And we could do that, and it's fine. It'd just be a little bit more work for us in the end. So let's not do that, and let's instead, this is the better idea and the idea you should take, is use this information that they've given us of f of 1 equals 3 to figure out what a is. And you're like, well, how is that going to help us? Well, keep in mind what this means. This means that if you plug in 1 for x, you should get out 3 for y. That's literally what f of 1 equals 3 means, is that x is 1 is your input, 3 is your output. So if I apply that to this problem, then if I plug in 1 for x, so I have 1 plus 1 times 1 minus 2 times 1 minus 4, then I should get my output, which we said was 3. Okay, well, this gives me a little bit of math to do. That's easy math. So a times 2 times negative 1 times negative 3 equals 3. 2 times negative 1 is negative 2 times negative 3 would be a positive 6. So a times 6 equals 3. We'll then divide by 6, and I get a equals 1/2. Okay, so now I can go back to the problem that I already had. So 1/2 times x plus 1 times x minus 2 times x minus 4, and then I can FOIL that whole thing out. So x times x, I'm going to keep this 1/2 here, that's going to stay there till the end. X times x would be x squared, minus 2x plus 1x would be minus 1x, minus 2 times x minus 4, and I distribute again. X squared times x would be x to the third. X squared times negative 4 would be negative 4x squared. Negative 1x times x would be negative 1x squared. Negative 1x times negative 4 would be a positive 4x. And then negative 2 times x would be negative 2x. Negative 2 times negative 4 is positive 8. Still got that 1/2 in front. I'll deal with it last. Simplify. So 1/2 times x cubed minus 5x squared plus 2x plus 8. And now I get to distribute by 1/2. Or distribute 1/2, not distribute by 1/2. 1/2 times x cubed, I'd have 1/2 x cubed minus 5/2 x squared plus 1x plus 4. And that would be my entire polynomial. So write a polynomial with zeros of -3, -2, and 5, and given that the leading coefficient is 1. Okay, that's a good thing. If the leading coefficient is 1, that means that a is 1. It's a nice, easy problem for you to work out. Okay, so we want that leading coefficient to be 1. It just makes our life pretty sweet and simple. So if we know that we have zeros of a 0 of 3, -3, I'm sorry, then we have a factor of x plus 3. And if we have a 0 of -2, then we have a factor of x plus 2. And if we have a 0 of positive 5, then we have a factor of x minus 5. And I know my leading coefficient is 1, which means that, like, based on the previous two problems, I would just put a 1 here that I would have to multiply by. Well, multiplying by 1 is the same thing as it's always been, so that's, like, nothing new. So now all I need to do is just FOIL and get this problem worked out. So x plus 3 times x plus 2 is going to be x squared plus 5x plus 6 when you FOIL that out, times x minus 5. Well, that's going to be a little bit harder to FOIL. So x squared times x would be x to the third minus 5x squared plus 5x squared minus 25x plus 30x minus 30. And then I just combine my like terms. Well, that'd be x cubed. Those would cancel. Plus 5x minus 30. And that would be my complete factorization. Okay, so this next one, write a polynomial with a 0 of 4. So if the 0 is 4, that means that the factor is x minus 4. We have to keep reading. It says, and a multiplicity of 3. Remember, we just had a problem like this earlier where that multiplicity meant that there's going to be an exponent there. So this is really x minus 4 to the third, which would be the same thing as x minus 4 times x minus 4 times x minus 4. And that's what I need to FOIL. So x minus 4 times x minus 4 here would give me x squared minus 8x plus 16. I need to multiply that by x minus 4. If you don't know where I'm getting this stuff from, actually work it out and make sure you get the same thing I do. And then x squared times x would be x to the third minus 4x squared minus 8x squared plus 32x plus 16x minus 64, and I'm just combining like terms, so I would end up with a polynomial of x cubed minus 12x squared plus 48x minus 64. And that would be my polynomial to the answer to this particular question of a polynomial with a 0 of 4 and a multiplicity of 3. And again, it had that phrase, the leading coefficient is 1. And that just means there's a 1 right here. That's what we want. If we want that one, we don't have to do near as much work. So there's a fancy property of conjugates. Conjugates, I hope you remember, would be something like if I have 4 plus 2i, the conjugate of that would be 4 minus 2i, okay? So the conjugate theorem says that, or the properties of conjugate says that if a plus bi is a 0, so for example, if 4 plus 2i was a 0, then 4 minus 2i had to be a 0 too. And we talked about that a little bit on Monday, because we had a problem where we talked about the fact that, remember, if you've got the i's have to do with square roots. When you take the square root, there's always a positive and a negative. So if you know 1 0, you actually know 2 zeros. So I need to find a polynomial with zeros of 3 and 2 plus I. Well, the first part's simple. If it has a 0 of 3, then it's got a factor of x minus 3. Things get a little more complicated when you start looking at the rest of this. If I have a 0 of 2 plus I, that means I have a factor of x minus 2 plus I. That also means that there is a 0 of 2 minus I. My imaginary numbers, my i's come in pairs. You want to know how to remember that? Think about your i's. How many of them do you have? You should have 2. So since you have 2 i's, then you're going to have 2 i's in this problem too. They come in pairs. So that means my other factor, my third one, would be x minus 2 minus I. So notice the sign here didn't change when I flipped it into factored form. I made the whole thing negative in the front. Okay, and you're like, oh my gosh, how do I multiply this? Well, let me give you some words of advice. Multiply these two together first, because a bunch of stuff's going to cancel out, and that's what we want, okay? So multiply those two together first, and then multiply by that x minus 3. So if I'm multiplying this, I have x times x, which is x squared. And then I have x times a negative 2i. So that's going to be negative 2 minus I x. And then negative 2 plus I times x. That'd be negative 2 plus I times x. And then negative 2 plus I times negative 2 minus I would be plus 2 plus I 2 minus I. Okay, let's fix all that before we move on. Because you're like, oh, this is so bad. It's really not as bad as you think it's going to be. So x squared, I need to do some distributing. That's going to be a negative 2x. That's actually going to be a positive 2ix. Because two reasons. Number one, I'm distributing a negative 1 times a negative I. And then I'm multiplying it by an x. So that's where that positive comes from. So then this becomes negative 2x and then negative 2ix, which the beautiful thing is some of this stuff is going to start canceling in a second. And then I FOIL over here. 2 times 2 would be 4 minus 2i plus 2i minus I squared. Okay, my 2ix's are going to cancel. That's what I want. I can combine my negative 2x's together. So I'm still going to have x squared. My negative 2x and my negative 2x together gives me a negative 4x. And then I have my plus 4 and my minus I squared. And like, well, why did those combine? Because remember, I squared is really negative 1. So negative 1 is really a positive 1. So I get 5 there. And you can go through and do the math in more detail if you need to, but I promise you that's what you're going to get. And then we need to multiply that by x minus 3. So we FOIL x times x squared is x to the third minus 4x squared plus 5x minus 3x squared plus 12x minus 15. And we simplify. end up with x cubed minus 7x squared plus 17x minus 15, and that's my polynomial. I know you're like, oh my gosh, we're done with that problem. Yes, we are. It only took us 4 minutes to work it out. So, what about if I have zeros of -4 and 3 minus I? Well, same thing. If I have a 0 of -4, then I have a factor of x plus 4. And if I have a 0 of 3 minus I have a factor of, here's what really happens. It becomes x minus 3 plus I. Both these signs ends up changing. That's really what happens. And then, don't forget, if I have 3 minus I also have 3 plus I. So that factor would be x minus 3 minus I. Please multiply these two together first. It's going to make your life so much easier. So much easier. So you multiply all this out. I'm about to pause it, and I'm going to do all the math, and then I'll unpause it. So you probably should do the same. So doing all the distributing with the x minus 3 plus I and the x minus 3 minus I, we get x squared minus 6x plus 10, and then we FOIL that. So x cubed minus 6x squared plus 10x plus 4x squared plus 24x, minus 24x plus 40. And then just combining our like terms, we end up with a nice pretty answer of x cubed minus 2x squared minus 14x plus 40. And that would be my polynomial that would provide the zeros that it asked for. And I know you're getting tired. We are almost done, okay? So, a couple things. A polynomial function with real coefficients of odd degree. So that would be something like x to the third, x to the fifth, x to the seventh, must have at least one real zero because imaginary zeros occur in pairs. So like for example, let's look at x to the seventh, okay? So if I have a polynomial of x to the seventh, that means that polynomial has 7 zeros. That's my possibility. It has 7 zeros. Well, first option is that always all 7 of those could be real. But what this is telling us is this is saying that because imaginary zeros come in pairs, like remember that plus 2i minus 2i, that whole conjugate thing we just talked about, that I could never have, it's not a possibility, so don't write this, I could never have 6 real and 1 imaginary, because that's not possible. It's not possible to have 1 imaginary. I must have 2 imaginaries. So my next possible combination would be then that I could have 5 real and 2 imaginary zeros. Or I could have 3 real and then I would have 5 imaginary. Or I could have 1 real, and then I would have 6 imaginary. Sorry, there's a typo. That should be 4. That makes way more sense. So these are all of my possible combinations, and notice this is important, that all of my imaginaries came in pairs, 2, 4, 6. So then, the other option is that a polynomial has real coefficients of an even degree. So an even degree would be something like x to the second, x to the fourth, x to the sixth. And it can have no real zeros. That's a possibility. Well, that makes sense. Because if I had a polynomial of degree 6, then it would have 6 zeros. Well, they could all be real. I can't have 5 real and 1 imaginary because it doesn't work. I can have 4 real and I can have 2 imaginary. Or I can have 2 real and 4 imaginary. Just has to add up to 6 every time. Or my final option is I could have 0 real and I could have 6 imaginary. And that's what this rule is saying here, is that it is possible, not saying it's going to happen, to have no real zeros if it's even, which we figured that out down here because we had 0 real. The other one is saying that it must have at least 1 real 0, and that showed up right there where it said we could have 1 real and 6 imaginary. So if I have, I'm so tired of talking.